This lecture is going to be about plotting, and I'm just going to provide a brief introduction to a few of the plotting functions and mechanisms in R. Um, first, the lecture is going to be divided into two parts. The first part I'm going to talk about the base plotting paradigm, and then in the second part I'm going to talk about the lattice plotting paradigm. So the basic idea with plotting in R is that there are a couple of packages that control the plotting engine and how things work. The main one, of course, is the graphics package. So the graphics package, of course, comes with R when you download it, and it's usually loaded by default. So this contains many of the basic functions for graphing, including the plot function, hist for histograms, box plot for box plots, and many other kind of very standard functions that you probably are already familiar with. The other major package for plotting is the lattice package, and this code contains code for producing what are called trellis graphics. This system is independent of the base graphic system, so that it has its own functions like XY plot, BW plot, level plot, and they don't intersect at all with the plot or the hist or the other functions in the base graphic systems. So usually you have to decide, are you going to use the base graphic system or the lattice graphic system? And for the most part, most people will start with the base graphics, so that's what we'll start with here. There's another package called Grid, which implements a lot of the kind of low-level and kind of nitty-gritty details that are used by the lattice package. And generally speaking, you're not going to be calling functions from the Grid package directly, but rather this package will be working behind the scenes. Finally, the GR devices package, which stands for graphics devices, contains all of the code which implements the different graphics devices that R can use, including the X11 device, the PDF device, the PostScript, PNG, all kinds of things. So these are the things that you can export graphics to, whether they be to the screen or to some sort of file. You will occasionally call these types of functions directly, but for the most part, the code in this package is not, generally speaking, for the user. So when you go to make a plot in R, usually there are a couple of choices you have to think about. Maybe not consciously, but sometimes consciously. So the first is, what device are you going to use to make the plot? So when you call a base plotting function in R, like plot or hist or box plot, and there isn't already a plot window open, what will usually happen is that a plot window will open on your computer, and the plot will appear in that window. So this is so that the window in which the plot appears is called a plotting device. And depending on what type of platform you're using, there's a different name for that plotting device. On Unix, it's called X11. On Windows, the device is called Windows, and on Mac OS X, it's called Quartz. So for each one of these platforms, there's a function corresponding to X11, Windows, and Quartz, which launches the plotting window. So you have to think about first, where do you want the plot to be sent? Do you want it to be sent to the screen? Do you want it to be sent to a file so that you can include it somewhere else? Because there are different types of functions that you can use for those different types of operations. The other question that's related is, what do you want to use the plot for? Do you want to just show it on the screen to look at some data, maybe temporarily? Or is this plot going to end up in a paper, so it's going to be like a publication type of thing? Are you going to use it in a presentation, so like a PowerPoint slide, or like an overhead type of projector? And so these kinds of considerations will affect a little bit the types of things that you put into your plot. For example, if you're going to be in a presentation type of setting where there's going to be people sitting, 200 feet away, you probably don't want to have very tiny little fonts with lots of little dots and things like that, because they won't be visible from a long distance. You're going to want to use bigger fonts, bigger plotting symbols, and things like that. Of course, if you're making a plot for a paper, then you can have a lot more fine detail, because people will be looking at a much closer range, and you can have all kinds of other kind of richer details in that kind of plot. So thinking about who the audience is going to be, where the plot is going to be presented, are key questions for how you're going to make the plot. So another question that's important is whether or not there's going to be a large amount of data that goes into the plot. If you're going to have lots of points, for example, if you're going to have thousands and thousands or maybe millions of points going into the plot, then that will help determine what type of plotting device you're going to use when you export the plot to either the screen or to a file. If it's just going to be a handful of points, maybe 10 or 15, then this is usually not an important consideration. And the last one is whether or not you're going to be able to need to resize the graphic. So do you want your graphic to be set at a specific resolution, or are you going to want to make it kind of larger and smaller without compromising the quality? Usually this will determine whether or not you use a vector format like PDF or PostScript, or a bitmap format like JPEG or PNG. The next question you're going to want to ask yourself when making a plot is what graphic system are you going to use? The base graphic system or the grid/lattice system? Generally speaking, you can't mix these two systems, so you're going to have to kind of choose one set of functions over another set of functions. So we're going to talk about the base graphic system first. And the basic philosophy of the base graphic systems is that you kind of construct a plot piecemeal. So the idea is that you kind of set up the plotting region, and then you can annotate the plot using different sets of functions that will add to the plot, and then for example, you can maybe put some points on the canvas. You can draw a title. You can add some axis labels. You can maybe annotate some of the points in the plot. And add some colors and things like that, add a legend. And this is all done one by one via different function calls. And so usually the process of making a plot involves a long series of functions where you kind of add things one by one. Many people find this conceptually a simpler process and often allows the construction of the plot to mirror the thought process. So you might be thinking, okay, I want to put these points on the screen, and then, oh, I want to add this label, and then, oh, I want to change the color here. And so it kind of mirrors the thought process a little bit. On the other hand, the lattice and the grid graphic system, the way that you make plots using the lattice package, it typically is via a single function call. And so the idea is that you kind of throw all the details into a single function, and then R makes the entire plot at once. So there's no adding of this and adding of that. And so in some sense, you kind of have to think of everything in advance. So you can put them all into the single function. So if you're going to make a scatter plot via the XY plot function, the XY plot function has a large number of options that you can specify to kind of set the axis labels, the colors, and the types, and the plotting symbol and things like that. So this is the kind of thing that makes it a little bit different from the base package. The base graphic system, because a plot will generally consist of a single function call rather than a series of function calls. The advantage of using the lattice approach is that R can automatically calculate all the spacings and the margins and the font sizes, and etc., so that everything kind of looks nice from the get-go, rather than you have to kind of manually calculate that as you go. So let's talk about the base graphic system. The base graphic system is a very powerful system for creating two-dimensional graphics, and for the most part I'm going to talk about two-dimensional graphics in this lecture. And the most fundamental function is the plot function. And usually you call plot with two arguments, a vector x and a vector y. So obviously the x vector specifies the x coordinates for the two-dimensional plot, and the y vector specifies the y coordinates. Another function, of course, is something like hist, which only takes a single argument, and it produces a histogram showing the distribution of that numeric vector x. Both of these functions will launch a graphics device if one is not already open. So typically when you start up R, you're not going to have a graphics device open. So the first time you call plot, it will launch and you'll see a graphics window open. And then after it launches the graphics window, it'll draw the plot on the device. So if the arguments to plot are not of some special class, so if you're just passing it a numeric vector or of some sort, then the default plotting method is called. And the default plotting method has many arguments because it lets you set things like the title, the x-axis labels, the y-axis labels, etc. And you can specify these arguments if you wish, or you can use the defaults. So the base graphic system has many other parameters too, which are not necessarily arguments to the default plotting function. And all of these arguments can be set and tweaked and modified, etc. And you're going to have to know at least some of them to know how to customize your plots. Most of the parameters are documented in the help page for the par function. So the par function controls all the graphing parameters. As I say here, it wouldn't help to memorize this help page if you're going to be doing a lot of plotting. So the par function is used to specify global graphics parameters so that anything that you set in the par function will affect all plots that you make in a single R session. So if you specify an option to the plot function, that will affect that plot, but it won't affect, say, the next plot if you specify a different option. But anything that you set using the par function will affect all of the plots that you make. So sometimes this is useful to save yourself from having to specify an option every single time when you call plot. However, any option that's specified using the par function can be overridden by specifying it in the plot function for a specific plot. So a couple of very important options that you should definitely have memorized are the PCH option, which controls the plotting character or the plotting symbol. The default is an open circle, but there are many options that you can choose from here. LTY is the line type, so if you make a plot that has lines in it, for example, like a time series plot or something like that, it specifies what type of line is going to be drawn, and the default, of course, is a solid line, but you can have a dashed line, a dotted line, a dash dotted line, etc. LWD is the line width, so it controls the thickness of a line that's drawn. Col is the plotting color. And this determines what color the plotting symbol, which the default is the open circle, will be plotted in. The default, of course, is going to be black. LAS is another nice option which specifies the orientation of the axis labels on the plot. A couple more options here. BG is the background color for the canvas. The default is going to be no background color. Mar is the margin size, and this specifies the margin around the plot. So there's 4 sides of the plotting region, and you can have a different size margin for each side. OMA is the outer margin size, which is the kind of the outside region of the plot window. And then the 2 important options for setting the number of plots on the canvas, which is MFRow, and MFCol, which can be set separately. They specify the number of plots per row and column. So, for example, if you want to have more than one plot, so you have 2 plots or 4 plots or things like that on the canvas, you can set the MFRow and the MFCol options. The only difference between the two is that when you specify MFRow, the plots are filled in row-wise across the canvas, and when you specify MFCol, the plots are filled in column-wise, kind of down the canvas. So you can look at the default values that are specified for the various par options. So for example, the default for LTY is solid. So this is a solid line. The default for LWD is 1. So 1 is kind of the standard thickness. As you increase the number, so if you go to 2, 3, 4, the thickness increases. So you can kind of adjust, and you can use this on a numeric scale. So you can have an LWD of 1.5 if you want, and that will be somewhere in between 1 and 2. The default color for the plotting is black, and the default PCH is 1, which is the open circle. For BG, you have transparent, so this means that the canvas does not have any color on the background. You can specify a background color if you want, but this is, in my experience, fairly uncommon. The Mar option specifies, again, the margins, and the way this works is that there are 4 numbers, and each number represents the size of the margin for a different side of the plotting region. So there's 4 sides to the square plotting region. So and you can think of it as going clockwise around the plotting region, starting at the very bottom. So think of the x-axis, that's the first side, the y-axis is the second side, the top of the plot is the third side, and the right side is the fourth side. So you can see that the x-axis, the bottom of the plot, has the largest amount of space. It's a 5.1. The y-axis has 4.1 for the amount of space. The top of the plot has 4.1, and the right side has 2.1. So the right side of the plot has the least amount of space. And you can adjust these numbers if you want to make more space or less space for each side of the plot. But the Mar option always is a vector of 4 numbers, so 1 number per side. The outer margin is a region that's just outside the margin, and again, there's 4 sides to this. And so the default for the outer margin is going to be 0. And the outer margin is really only relevant if you have more than 1 plot per canvas. So if you only have a single plot, you're generally not going to be using the outer margin. But if you have many different plots, then sometimes you want to have a label or something like that for that is relevant to all the plots, not just a single plot. MF row and MF col I described before, the defaults are 1, 1, so that's one plot per row, one plot per column. And so that's, of course, just means a single plot. You can, if you want to specify, say, 4 plots, you want to have like 2 by 2. Then you can have 2 plots per row, 2 plots per column, and that kind of has that's a 4 square type of thing. If you wanted to have 4 plots but all in a single row, then you can specify MF row would be 1 and then 4, so it'd be 1 row, 4 columns, things like that. So a couple of important base plotting functions. Of course, plot is probably the most basic. It makes a scatter plot. It may make another type of plot depending on the class of the object being plotted. So if you have an object that has a special class that's not a numeric vector or it's not an integer vector or something like that, then plot may make a different type of plot. But for the most part, we're going to be making scatter plots with this function. Lines is a function that adds. So the following functions, are going to add to a plot. They're not going to make a plot by themselves. So functions like lines, points, text, etc. You cannot call them unless you have already constructed a plot on the plotting device. So lines adds lines to a plot. So basically, it connect the dots. So if you give it a vector of x values and a vector of y values, it will put those points on the canvas and connect the dots between them to create lines. Points basically adds points to a plot. It's kind of like lines, but it doesn't actually draw the lines in between the points. So you give it a set of x values and a set of y values, and it puts those points on the plot. Text adds text labels to a plot. So you give it some coordinates, and it will put the text at those coordinates on the plot. Title will add a title to the top of the plot. You can also use title to add things like x-axis labels, y-axis labels, and subtitles and things like that. mText adds text to the margins, either the inner margin or the outer margin of the plot. And axis annotates the axes, so like things like the tick marks. You can add special labels to the tick marks if you don't want the defaults. So there are a number of different types of graphics devices that you can send plots to besides the screen. So the screen will just be whatever the default is for your platform. So on X11 on Unix, Windows on Windows, and Quartz on the Mac. But there are other types of devices that you might want to use. Probably the most common is the PDF device. And this is very nice for making kind of print quality graphics, for line type graphics. It's a vector format, so it resizes very well without losing any quality. And it's viewable on pretty much any modern platform. The PDF. So if you're making a scatter plot or that kind of thing, that's a line type graphic. It's going to be suitable for PDF. PostScript is an older format, kind of a predecessor to PDF. It's generally not used very often right now. And so I would recommend against using it. Xfig is a format that's specifically for Unix and is useful if you want to edit the plot by hand, but it's not particularly common. So bitmap formats are very important for graphics that are things like images, or if you're going to make a graphic that has lots and lots of points on it. Typically, you're going to want to use a bitmap format because it reduces the size of the graphics file. So, for example, if you have a scatter plot that has 2 million points on it, if you make a PDF file of that, the PDF document has to specify kind of a little bit of information for every single one of those points. So 2 million points may be a lot of things, and the PDF file is going to be very, very large if you make a PDF version of that graphic. However, a bitmap bitmap format will always be the same. It just specifies the number of pixels, and so you don't have to specify information for every single object in the plot. And furthermore, most of the bitmap formats are compressed, and so the file sizes tend to be a lot smaller. So if the file size is important to you, then you're going to want to think about bitmap formats. The disadvantage of bitmap formats is that they generally don't resize very well. So if you try to resize them, you'll lose some quality. And so they're designed to be of a specific size for a specific resolution, and they don't resize very well. So PNG is a very nice format. It's good for line drawings, images with solid colors, so for things like scatter plots, and it uses a lossless compression algorithm. For those of you who are a little bit older, you might remember the old GIF format. So it's kind of like the old GIF format. And most web browsers these days can read this format natively, so you don't have to worry about it not being able to be read in a web browser. The JPEG format, most of you are probably familiar with, is good for photographs or natural scenes. It uses lossy compression, and so you'll lose some quality, but the file size tends to be very, very small. If you use JPEG for line drawings, you'll probably see a little bit of distortion, so it's not particularly good for that. Again, it doesn't resize particularly well because it's a bitmap format, but of course, any computer, any web browser can read a JPEG file these days. Bitmap is a function that's used to create bitmap files in situations where you cannot use the PNG and JPEG functions. These are rare. They usually involve situations where you're running R in a batch mode, and so you can't call those other functions. So this can be used to create a variety of bitmap formats, but generally you will not need to use it in most situations. For example, if you're running it R on your laptop. Finally, the BMP format is a native Windows bitmap format that's usually used for specifying things like icons. So when you make a plot, there's kind of two basic approaches. First is if you want to send a plot to a file, you can first approach is to launch a graphics device, make the plot, add things to it, annotate it if you need it, and then close the graphics device. The other process is you can make a plot on the screen, annotate it if needed, and then you can copy the plot to another device. For example, you can copy the plot to another screen device, so another window, or you can copy the plot to a file. So copying the plot to another device can be useful because if you call a lot of different functions for making the plot, it can be kind of a pain to type all that code again if you just want to see the plot on a different device. So for example, if you want to save the plot to a file, usually the easiest thing to do is to say dev.copy to PDF, which will copy a plot to a PDF file. And then you can have a PDF version of that file, of that plot, excuse me, and then you can include that in a paper, include that in a presentation, etc. Of course, it's always good to save the code that you use to make a plot, because if you ever close R and then start up again and you want to make that plot again, you're going to want to have that code lying around rather than have to kind of rethink how you made that plot over again. So always save the code for making a plot so that you can reproduce it at a later date. Some basic functions though for copying plots are dev.copy, which just copies from one device to another device. Dev.copy to PDF, I mentioned already, copies from one device, usually the screen, to a PDF file. Dev.list shows how many open graphics devices there are. Dev.next will switch control to another graphics device because you can only plot to a single graphics device at a time. Dev.set can let you set which graphics device you're plotting on, and dev.off will close the current graphics device. So copying plots is not an exact operation, so if you have a plot that's on your screen and you copy it to a PDF file, it may not be exactly what you see on the screen just because there's some approximation that has to occur when you copy plots from one device to another.